Okay, so this is our potentiometer diagram right here, and right here, if you zoom in, you can see the actual potentiometer. We have it connected, these two leads here, so you'll notice that there are 3 leads, and right now we only have 2 of these leads connected. So this one in the middle will always stay connected, and for now we just have this one connected as well. Right here is what is a resistive material. So what happens is the longer that the distance that the electricity is to travel through the resistive material, the more resistance that the potentiometer will have, and the more V drop across these 2 leads there will be, thus changing the voltage in the circuit. So for example, right now, here, so if you spin this knob and say this, so this is what they call the wiper here that's connected to the knob. So as you spin it, this wiper will move along the resistive material, changing the length of the circuit that's in this resistor. So for example, right now, because it only has to travel this far, that's barely going to have any resistance. Whereas if you spin it all the way, and this would go all the way to here, then it would have to travel the length of this entire resistor and then to the other lead. So that would be the most resistive, thus creating the most V drop and decreasing the voltage in the circuit the most. Okay, so now you'll note that it's reading 9.81, so its resistivity is all the way up, and you'll notice that I now have it connected to the left and the ground. So if you go over to this diagram, I have it connected here and here. So that's almost as if this wiper has been switched all the way over to here. So the electricity has to travel all the way along that, and that's why the resistivity is so high. And that's why if you were to connect it back to this one, the resistivity would be 0 or close to it, because it barely has to travel any distance at all through the resistor. Here we have a example circuit using the potentiometer, which is right here. You can see this is the symbol for it in circuitry, is that resistor with an arrow through it. And then right here is a normal resistor. And then over here we have the 9-volt battery. So this creates a full circuit. And so if you come over here, you can see that I've created the same circuit. And as I talked about earlier, the potentiometer, by changing its resistance, by changing its internal resistance when we turn that knob, it will increase or decrease the amount of voltage drop across its terminals, which will then in turn increase the amount of voltage across this other resistor right here and right here. So for example, right now, I'm going to measure the voltage drop across this 100 ohm resistor. So it's reading, right now it's reading 0, because I have the potentiometer turned all the way to the left, which means that it has almost 10,000 ohms of resistance, so all of the voltage drop is across the potentiometer. But as I turn this, we should be able to see the voltage drop across the resistor jump. See, there you go, the voltage drop across the resistor is now a full 8.75 volts right there. So that means that this potentiometer, now that it's turned all the way to the right, is almost acting just like a wire. There's almost no resistance, and so there's no voltage drop across the potentiometer, so the rest of the voltage drop goes across this 100 ohm resistor.